Good day everyone. So let us now learn how to filter image collections. Why do we have to filter image collections? Because we need to focus on our area of interest and also we need to select quality images that we can use for our processing. Okay, so there are actually a lot of filters. As you can see right here, if you go to the left side here, we have the docs. If you press the drop down for the filter, there are lots of filters that you can use. But for this video, we'll be using the geometry filter, the date filter, and also the metadata filter. Okay. So the first things first, let us search for our data set. So I've already typed it in here, Sentinel-2, and then we will use this level 1C. You can select other data sets if you want. Okay, so let's name it Sentinel underscore 2. Press enter. Okay, so we have it loaded in the code editor. So let's try to print how many images there are in this entire collection. So to do that, you just type in here print and then sentinel2.size. Okay. So we have to wait a bit. So I will fast forward it because this will actually take a long time. Okay, so there are actually 19,712,495 images for the Sentinel-2 level 1C. So there are actually a lot. So actually it took about 10 minutes to get this result. Okay. So that's why, one of the reasons why we really need to filter. So the first filter that we're going to use is the geometry filter. So, but before we can use that, we must create a polygon in our area of interest. So let's say we take this town by Leyte as our area of interest. And then there are many ways to create a polygon. So you can create a polygon using the Earth Engine container for geometry. So you can go to eGeometry polygon, or you can simply click here in the polygon icon that says draw shape. Okay. So if you do that, so this is a lot easier. Just go here and click here. So let's focus on this part right here. Okay, so let's say this is our area of interest. Okay, so as you can see here in the second line of code, it's already added. So var geometry, a polygon with 12 vertices. So let's change the name to our ROI. Okay, so now we can now use the geometry filter. So let's create a variable to hold this object. So filtered, let's just name it filtered geometry. Okay, so it's equal to, so our image collection object sentinel2 dot filter, and then you can then input a filter here, a filter object inside it as an argument. So ee dot filter dot bounds, and then we can then input our ROI. So if you're curious what's happening here, so you can just search in the docs. So let's say we want to know what this does. Sentinel2.filter. So Sentinel2 is an image collection, right? So let's go to the image collection. Let's look for image collection, and then let's look for filter. Filter. So here we have it. So you can use, you can put another filter. You can put another filter as an argument. Okay. So in this case, we are using the filter bounds, and then we are inputting our ROI as an argument for that particular filter object. Okay, so if we print the filtered geometry.size, let's see how many images we have. Okay, so we have 680 images. So that's actually pretty cool. So way less than 19 million, right? Okay, so we now have our images for 680 images for this area of interest. Now let's apply another filter. So var filtered date is equal to. So we're no longer going to use the Sentinel-2 here. So we are going to use the filtered geometry. So this has the 680 images that we can use. Okay, so filtered geometry dot, that filter, yeah, that filter, and then ee dot filter. We create another filter here, and the date, filter dot date. So again, we're going to input string format. So 2021. So let's say we're going to use the images from the year 2021. So from January 1 to August 30, let's say. Okay, so now let's see how many images we have. So from 680, we now have 108 images that as a result of these two filters. So again, we filtered the 19 million, and then we filtered it so that we have imagery in this particular area. So we got 608 or 680. And then after filtering it again for the date, from January 1, 2021 to August 30, 2021, we have 108 images left. Now let's try to apply another filter. This is called a metadata filter. So var let's see, filtered metadata. So you can use any variable name that you want. So filtered underscore date, and then filter. So let's see, filter that less. So this is less than filter that less than. Okay, so because we are going to use here the cloudy pixel percentage property of this data set. Okay, so less than 10%. Okay, so you might be asking, where did we get this cloudy pixel percentage? So let's now go to the data catalog. If you go to the data catalog, we have different tabs here, right, for the information about the dataset. So these are the different image properties that you can use for filtering. So in this case, I'm going to use the cloudy pixel percentage because I want to filter the images so that there is less cloud coverage. Okay, let's go back to our editor and let's try to see how many images are left. Let's run it. So we only actually have 5 images. Okay, so let's now try to display these, like the median of these 5 images. So filtered metadata dot median. So let's take a look what this dot median does. So image collection median. So reduces an image collection by calculating the median of all values at each pixel across the stack of all matching bands. So bands are matched by name. Okay, so that's what median does. So if you run it, so as you can see, this is still a very huge area because this is one image. This is the coverage of one image. And then we will learn in a later video how to clip this particular image using our polygon that we just created for our area of interest. Okay, but essentially we've filtered down from 19 million images in the Sentinel-2 level 1C to 608 using the geometry filter, and then 108 using the date filter, and then 5 using our metadata. Okay, so that is how we filter images. So we can change the visualization properties here. So 4, 3, 2. Then let's try this one. Okay, so there you have it. If we take a look here, so the cloud coverage is not that bad actually. So let's turn this off first. So it's a good quality image. So there are not many clouds. Okay, really nice. Okay, so that's it for this video. I hope you learned something new, and I will see you in the next one.